Hi everyone, and welcome to this lecture in P8105, a course on data science. This is the second in a collection of 3 videos on visualization and exploratory analysis. And in particular, we're going to look at refining some plots using ggplot. I'm going to start by giving an introduction to the material using slides, and after that I'll demonstrate this using a screencast. Feel free to skip around to the parts of the video you find most useful, and as always I encourage you to code along with me to get the most out of this. All the material is available at p8105.com. There are links in the description below. Awesome, let's get started. All right, so we're going to revisit some principles that have to do with visualization. One of the things that we said in the first of these videos is that a picture is worth 1,000 words. And we talked about this both from the perspective of how you communicate with yourself as an analyst and how you interrogate data, and also how you try to explain some things as a communicator, and that you're going to make a lot of plots. And I hope that's starting to become clear. What we didn't really emphasize is that a good picture is worth 1,000 words, but you can make some bad plots, and those plots are probably not going to be all that helpful in the end. These sort of 2 examples that we're going to look at here come from Carl Broman's top 10 worst graphics, and these are actual plots that appeared either in publication or online. This is a figure that seems to be showing 2 diagonal lines in separate panels for whatever reason. If you look really closely, you can see that there's maybe sort of a solid line on top of a dashed line, but this is just not really a particularly useful plot. And this, I think, appeared in one of the premier statistics journals that exists. And then you see something like this. This is sort of a screenshot of something that appeared online, and it looks like things are informative. You see sort of an increasing trend, but then you notice that all of the years are colored in exactly the same color, and you can't actually tell if there's anything that's going on here. This could very easily be an increasing trend, or if it turned out that this was 2017 and this was 2003, this could be exactly the opposite. So this is just sort of, just really, really poor communication. So I think, a good picture is worth 1,000 words, but I got to be a little bit more clear about what I mean by a good picture. And in this slide and in the next one, I'm mostly going to be borrowing from people who have thought an awful lot about this. And in particular, I encourage you to take a look online at the Creating Effective Tables and Figures talk by Carl Broman. The underlying principles, though, are sort of easy to distill. The idea is that you should show as much data as you possibly can. Meaning, if you can show everything that's going on in a data set, that's great. That's not always possible when data sets are really big or really complicated, but if you can show more of your data, that is generally speaking a good thing. You should include things that are relevant, but if you are adding something that is just there for no particular reason, then it's probably not a particularly useful thing to include. And then when you are asking a viewer of your graph, when you are trying to communicate something that involves a comparison, you should try to make that comparison easy to make. Meaning that if you have multiple groups, they should be in an order where the groups that you want to compare are side by side to the extent possible. Side-by-side comparisons are usually a little bit easier than vertical comparisons, meaning if you've got 2 panels, put them next to each other instead of stacked on top of each other. If you have multiple panels, try to use common axes so that it's easy to go from this to this and understand what's going on. Color can be a relevant way to highlight groups, meaning that if you want both to have sort of say here, a treatment and control, that's great. If you wanted to have multiple colors here, that's maybe something that's going to be helpful as well. The sort of figures down here at the bottom are taken directly from this talk by Carl Broman, and you can sort of see they actually convey the same data sets. You have a treatment and a control group, but the one on the left, it may look simpler, but it is in fact a lot more effective in the sense that it shows both raw data. It gives you a way to easily compare what's going on in a treatment group and a control group. It includes some additional information, something like a mean and a confidence interval to facilitate that kind of a comparison. And it doesn't have a whole lot of superfluous stuff floating around. The graph on the right doesn't show any of the data. It's hard to compare exactly what's going on. There's a 3D pyramid for some reason, and if you wanted to get an idea maybe of like what the actual values are, you can sort of say, well, I guess like this figure looks like it's sort of the peak of the pyramid is somewhere around here, and maybe the peak is somewhere around 30. It's just it's not really conveying all that much in a way that's useful for somebody to try to read. A last thing, and I'm not going to go into this in a lot of details, but pie charts are in general just awful charts to have. Don't use pie charts, with the one exception if you are using your pie chart to convey how much pie you have eaten and how much pie you are going to eat. That's maybe the only time that you can really use a pie chart. I also wanted to bring this up. I thought this was sort of a useful distillation. This is coming from somebody who really spends a lot of time working on data visualization and graphing. This is the Twitter handle @storywithdata, and there are some guiding data visualization principles. Partly this is for you, and partly this is sort of how you can implement these. When I say partly for you, you should understand what you are trying to communicate with a graph, and you should also understand who your audience is. If you understand both of those things, hopefully you are able to communicate effectively in a graph where the audience that you're communicating to looks at your graph and almost immediately understands, draws the conclusion that is relevant for them to draw. There are some other things that are a little bit practical. Try not to overcomplicate things. Get rid of frills that are not really necessary. Make it clear where to look. That is, sort of facilitate comparisons and make it obvious which comparisons you want somebody to look at. And then a final point here, words make a graph accessible, meaning that a chart by itself is probably not going to tell you all that much, but if you have sort of useful captions, titles, axis labels, things like this, then that's going to make your chart more accessible. I also want to be clear here. I'm sort of talking about good pictures being worth 1,000 words. This is not necessarily the same as figures that you are going to send to everybody else. If you make a lot of figures, the figures that you create for yourself should be good. They should be helpful for you as an analyst, and so you don't always have to worry about all of the details that you might put into a figure that you are going to send to somebody else or you're going to publish online somewhere. But even with that, you should try to make sure that the figures that you are making for your own information are informative. The publication quality pictures, or even just figures that you are really going to send to somebody else, may require a few more getting into the details than are necessary just if you want to communicate with yourself or you're trying to understand something going on in a data set. So we talked in the first video in this collection about the use of ggplot, and we started out mostly focusing on how you construct a ggplot object. What is sort of the underlying logic of how these things work? And namely, you're going to define a data set, use that to define aesthetic mappings from variables in your data set to elements that appear in a graph. And then you're going to define the geometries that you want to see. You're going to define scatter plots or box plots or histograms or smooth curves or something else. And those are sort of the main things, the basic things that go into creating a ggplot object. We also talked a little bit about facets, meaning you can sort of create a similar figure across multiple panels if you want those additional panels to reflect some categorical variable in your data set. That's a helpful thing to do. Adding statistics, means, median, standard errors, things like this can help communicate effectively as well. A final piece that we have not talked about, but we will today, are scales. And I'll sort of pause briefly to describe what I mean by scales. Aesthetic mappings tell you how a variable maps onto some graph feature. And usually that process is invisible, it's behind the scenes, it's something that happens in the background. But there are some decisions that get made in how these things happen, and you as somebody who is creating a graph do have some control over those things. The first thing that you might want to do, for example, is not just have this variable mapped to x, but you might want the x-axis to have tick marks at very specific locations, or you might want it to be transformed in some way. And similar with the y-axis, you might want the color variable, the variable that gets mapped to color, you might see what that is and determine you want a different color, a different sort of color mapping, some different behavior there. So generally speaking, scales are going to control the behavior of things that happen behind the scenes with the aesthetic mappings, and that's helpful to sort of know. So that's a lot of what we're going to end up talking about today, is sort of how you can further customize your charts depending on the goals that you have. Some of this is going to have to do with labels. Some of this is going to have to do with things that are controlled by the scales. Some of this is going to have to do with the graph themes, the other sort of visual representations of data, how you might combine multiple panels in a way that's different from faceting. All of those are going to be things that it's helpful for you to understand so that you can create graphs effectively. A final point that I'm going to talk about today is the idea that ggplot is built around the idea of a tidy data framework, and we've seen that in the first video, at least to some extent. The idea is that you have all of your data in a data frame, and that data is organized in a nice way, and then you put that into a plot object, determine your aesthetic mappings and your geometries, and you're sort of off to the races. Often, though, when it comes time to create a particular plot, you think to yourself, well, I know what I want the plot to look like, but somehow I can't quite get that to appear from the data that I have. And one of the biggest issues, especially when you're learning both tidy data and data manipulation and also ggplot roughly in parallel to that, is the sort of back and forth between data organization and data manipulation and data tidying and the plots that you want to be able to make. Very often, how your data is organized is going to affect what you are able to plot. And even more than that, if you're having trouble making a plot, often that's an issue with data organization, with data tidiness, that's sort of one step up. So toggling back and forth between tidying and transformation and visualizing sort of in this region of the data analysis pipeline, that can be a useful way to sort of figure out what it is you're trying to plot and figure out how you're going to do that. One particular thing that comes up a lot and that we will mention this time and revisit in later videos is the idea that categorical predictors are going to show up in a particular order in a plot. And if you want to facilitate a comparison by reordering those things, you do sort of have to understand what's going on with factors. And we'll see an example of that today. And so with that, I think we're going to switch to a screencast. Fantastic. All right, I've got my project infrastructure already set up from the first video here, and I made a couple of edits before I got started recording today. In particular, I duplicated the viz1 RMD file. I've got viz2 here. Let me open up this project and we'll take a look at what's going on. So my viz2 RMD, I've made a couple of edits so far. I updated part 1 to part 2, super important. I also, instead of loading GG ridges, we're not going to make any ridge plots today, but we are going to use patchwork to arrange multiple panels. We'll see that a little bit later on. So we keep tidyverse, and we've added patchwork here. I'm going to load the weather data set, and then I've gotten rid of all of the other code that I used to create some plots. So I'm going to run both of these chunks real quick. And then I'm going to knit to make sure that everything knits and looks the way that it's supposed to. And then what we're going to get started on is, at least initially, a plot that's very similar to what we saw last time. So let's use remember this plot. My goal in this video is we're not going to worry so much about how to use ggplot to create basic plots. We're going to sort of say you take a data set, you define your aesthetic mappings, you define your geometries, and it creates a plot. What we're going to focus on now are some of the more fine-grained details that you might use if you wanted to share this plot with somebody else, or you just wanted to improve its appearance for your own consumption. So we're not going to worry about having a particularly complicated plot, at least at the outset. What we are going to do is try to play around with that and modify it. So we're going to start with a really simple plot here. I'm going to take my weather data frame and wrong keystroke. I'm not going to minimize this. I'm going to add in a pipe and go to ggplot. Let's say I want X to be tmin, defining my aesthetic mappings, Y to be tmax, and I'll say that color is equal to name. So I've defined here 3 aesthetics, and then not pipe. This is plus. That's one of the mistakes that I make the most frequently, is putting in a pipe instead of a plus in ggplot. That's a story for another day. I think, boy, that's a real issue. Anyways, we're going to go into geom point to create a scatter plot here, and let's just make sure that this works. Okay, great. Actually, I'm gonna add in alpha here just to make this look a little bit nicer. Awesome. I'm such a fan of this plot. All right, what I'm going to do though is say, if this were a plot that especially that I wanted to share with somebody else, for me, this plot is probably sufficient to know what's going on. But somebody else looking at this might not know what tmax is. They might not know what tmin is. It wouldn't be immediately obvious what's going on here. It might help to have a caption that's explaining a little bit more information as well. So that's sort of the first thing that I'm going to do, is add in text or labels to go along with these things. And I'm going to copy and paste this plot. Again, this is sort of our starting point. And I'm going to add in here the labels. There are a variety of functions that you can use. You can specify xlab and ylab and some other things. I find it easier to just remember that the labs function controls the majority of the things that I'm interested in. So I can specify here a title, let's say temperature plot. I can specify an x-axis, minimum daily temperature. and I'll say degrees Celsius just to be clear what that is. Oop, gotta have some commas. Thank you, RStudio. I'm gonna change Y to maximum. And let me run this plot to make sure that things are sort of moving smoothly so far. Maximum, minimum, temperature plot, that all looks good. I'm gonna add in a caption here just to see that we can. And we'll say, what do we want to call this? Data from the RNOAA package. RNOAA package, temperatures in 2017. Okay. And let's run this. See how that looks. Great. So we've got a little caption underneath our plot. Looks awesome. I'm pretty happy with this. Again, this is the kind of thing that I think it's one of the easiest ways to make your plot a little bit more clear is to add in some text. It doesn't take really any time at all to add in these axis the axis labels of temperatures to go from variable names Tmin and Tmax to something that's a little bit more informative. And this is something that I strongly recommend you get in the habit of doing, especially if you expect your plots to be seen by somebody else. What we're going to do next is a little bit more complicated. Let me knit, and I'm going to commit this all to Git just to be a little bit more consistent than I had been previously. So this is plot and labels. Perfect. What we're going to do next is start to get an idea of what happens with scales. Now, when we define our aesthetic mappings, we know that X goes to Tmin and Y goes to Tmax and color goes to name. And those define an association between a variable and some feature of our plot. And that often happens a little bit by default. What exactly goes between this variable and this plot feature? Scales give you a way to take some control over that. And so the first thing that I'm going to do is start with the same plot. And I'm going to leave my labels in here just because I can. And what I'm going to do next is start defining some scales. The first scale that I'm going to use is on the x-axis. So I'm going to use scale x. And there are a lot of different things that you can do with scale x. Here, the variable that gets mapped to the x-axis is continuous. So I'm going to use scale x continuous. You often will use scale x discrete also if you want to control something and your x variable is a categorical variable or a factor variable. But the scale x continuous, I think, is a helpful thing. In my plot, you'll notice there are a variety of choices that got made. So we know sort of where the minimum is, where the maximum is. These choices to have tick marks and grid lines at -10, 0, 10, and 20, those are all features of the mapping between Tmin and the x-axis. And those are the kinds of things that you can use the scale x continuous to manipulate. So here I'm going to say, suppose I didn't want -10, 0, and 10. I'm going to define the breaks here to be -15, 0, and 15. And I think these have to be numbers. I think that's right. So let me just sort of try this. Great. So I've updated this. I get -15, 0, and 15. You can also tell this what labels you want to use to go along with these. It needs to be the same length here. And you might ask, like, why would you want to give yourself labels too? I might say here that I want this to be -15 Celsius. And if I could remember the symbol for degrees, I might put that here. I can't remember the keystroke off the top of my head, but let's just say -15 Celsius and then 0 and then 15. And let me run this. So I get slightly more informative tick marks, and those are the kinds of things that can be helpful, again, if you're formatting this plot for somebody else. But there are some other things that we might want to do in addition. So let me just sort of say, I'm going to leave this scale x here, and I'm going to add in a new scale, scale y continuous. And what I'm going to do for the y-axis, I mean, suppose in this case, I think probably this scale is completely reasonable, but suppose I wanted to do a transformation. Suppose I had something that had like a really long tail in one direction or the other. I could define a transformation here and do the transformation instead of just mapping Tmin here on, or sorry, Tmax onto the y-axis. I could use a square root transformation. I think, right? And so now I get from 0 up to whatever sort of the 30 is here, you're sort of seeing a lot of space between 0 and 10, and then less between 10 and 20, and less between 20 and 30. You can do a log transformation. Fingers crossed, I think you can do a log transformation. Yeah, and you get something here that's even a little bit different. Those, you know, again, in this case, it's maybe not super helpful. Another thing that occasionally comes up is position. You can put the scale by default is on the left side. You can put this on the right side if you want to. And you get sort of harder to read maximum daily temperature. Again, I don't know that I recommend this, but it is especially helpful to know that you can do transformations of your y-axis if that's something that you need to. What I'm going to do next is, so these are still the same plot, x and y scales. I'm going to take this same thing and let's look at color scales. Now, let's get rid of the scale x continuous and scale y continuous and sort of assume that I'm okay with that. Okay, but let's then sort of say that I have defined a mapping between the name variable and the color aesthetic, but I'm not super happy with this. There are a couple of things that I can do to update this, and scale color is going to be another one of these that controls the color attribute. It controls the color feature, and there are going to be a lot of options here. So the first one I'm going to use is scale color hue, and that's hue, roughly speaking, describes sort of the shade, the tone. I am out of my depth. I don't know it describes a feature of colors. It's as good as I'm going to be able to do. So one of the things that I'm going to specify here is H, which tells you something about the hue of a scale. And here we're going by default from 0 to 360. And let's just do something different. Let's do 100 to 200 and see what our plot looks like. Okay, not great, right? But we do have some control over what these colors look like. So now Waterhole is this sort of weird green color. Central Park is sort of a not really great looking green, and Waikiki is actually kind of about the same as it was before. Let me try 0 to 300. You know, it's ugly, but you can kind of at least tell what the differences are here. I will point out, in scale color hue and in scale color other things, you can rename so sort of in scale X, we used that argument so we used here labs to rename what's going on the x-axis. Here, if we want to define something different for the name, I can change the name of I can change the title of this caption over here using the name argument. This is a little bit strange, given that my variable is called name, but just sort of know inside of scale color here, I am using name to control what's going on right over here. Let me run this and hopefully that'll be more clear. Right, so here I have updated from the variable name, I'm now using an argument to put in the location here. And I think that's maybe a little bit better. Again, it's a little bit confusing given sort of the overlap between the variable name and the argument name, but hopefully that helps. Now I am going to sort of say that, gosh, using scale color hue to define your own colors, there are things that you can do here. And maybe you care an awful lot about graphic design and you're really good at these things. I am not good at these things. And so I use I also sort of dislike what's going on in the usual default ggplot colors. So I'm going to use something a little bit different here. What I'm going to use comes from the Viridis package, and I'm going to use scale color Viridis. I don't know if I'm saying that correctly. I'm going to get rid of this H argument, but keep the name argument, and let's sort of take a look at what's going on here. Wrong one. I guess it says discrete values was supplied to continuous scale. Scale color Viridis assumes that the value that you're putting in is a continuous value. If you want this to be a discrete variable, you have to tell it it's a discrete variable. Here, name is a categorical predictor. It's got three levels. And so the scale here does need to be discrete. Right? So let me run this. And I get a different looking color scale. I've got yellow and sort of greenish, bluish, and purple. And to me, this is both, maybe because I'm a little bit more used to it, I think it's a little bit more visually appealing than what we had seen previously. It also turns out that this color scale has some other benefits. And for that, I'm actually going to turn to Google and see if I can find Viridis color palette. The Viridis color palettes, let's see on CRAN, color scales from Viridis here. That's maybe not the right one. This is a little bit closer. So you get a sense here of what it looks like on a more continuous scale, but there are reasons that you might want to do this that we'll see in just a minute. The default is the Viridis palette here. You can specify a magma or a plasma or an inferno or one of this other one. And this is in comparison to things like the ggplot default and the R-base graphic default that are not great. Part of the reason that I like these is that for various color blindness the ggplot default looks bad and rainbow plot sort of mixes up two ends of the scale and so on. Viridis, if you show the same plot, this same color palette from Viridis and to somebody who is either colorblind or not, you end up actually preserving some of that scaling and making it a little bit more accessible in that way. It also prints to black and white a little bit better than some of these other ones do. So again, there are a variety of reasons that by default, I end up using this color palette for pretty much everything that I do. And again, I encourage you not to try to create your own color palettes, but to adopt one that you want to use. So let me knit again. What have we done? What have we added here? Takes a minute to make all these plots. And what I added was scales. That's it. Okay. So what I'm going to do next is move away from things that control specific mappings or fine-grained control of the mappings between the variables and the plot features. And now I'm just going to sort of talk about plot features that aren't data dependent, that just sort of are things like background color and font sizes, or sorry, font choices, things like this. And the way I'm going to talk about this is using themes. So let's start from the same place. And when I start talking about themes, again, what I mean are things like where this lies on my plot doesn't really depend on the mapping between a variable and a color. It doesn't really depend on much of anything. It doesn't depend on the data set. Where this caption is something that is sort of absent of data. And similarly, the choice of having gray backgrounds with white grid lines, that doesn't actually depend on anything that has to do with my data or my aesthetic mappings. Those are things that have to do with overall plot structure and appearance, and therefore are going to be controlled using something like theme. So the way that I'm going to, I guess, get started with this is by adding into the theme argument here, or sorry, into the theme function, I'm going to tell this to start out, I want the legend position to be at the bottom. Oops, let me run the whole thing. Yeah. All right, so now that's sort of shifted from the side down over here to the bottom. It's keeping the same information. It hasn't changed any of the data or the aesthetic mappings, but it turns out to be helpful here. And I guess when I started to type this, I saw there are a lot of things here: legend, background, legend, direction, key, size, margin, spacing. There are a lot of arguments that you might put in here to control what that legend looks like in a way that doesn't have anything to do with the variable, with the aesthetic mapping. So that's okay. Let's say that's great. What I'm going to do though is say, gosh, if I wanted to change more things, suppose I didn't like this gray background. Suppose I didn't particularly like not having a box around the outside. Suppose these are those are things that, depending on your aesthetic preferences, you might like more or less. And those are going to be controlled using themes also. So this is shift the legend. And now what I'm going to do is change the overall theme. So I'm going to start with this same thing. I'm going to get rid of that whole theme. I'll return to that in just a second. But suppose I wanted to change overall features of what this graph looks like. By default, what ggplot uses is called the gray theme. And what I'm going to say is you can change this. You can use theme black and white, for example, is sort of a popular one, where you get a box around the outside and it's sort of white background and gray grid lines. That's one I think that's pretty popular. I like theme minimal. I use this a lot of the time, which is almost the same. It just gets rid of the box around the outside and some tick marks. I don't know. Personal preferences here. There are some other themes that you can use. I think there's theme classic. What does theme classic look like? This, I mean, there's no grid lines in the background. I don't like this an awful lot. Up to you. There's people have pulled together a variety of themes in the GG themes package. There are a lot in here that are actually, I think, pretty good. There's the economist theme. Maybe we'll try this. Does this work? Oops. Let's try theme. That's probably closer. Yeah, well, is that what the economist looks like? That's not as nice as I thought it was going to be. What else do they have floating around in themes, in GG themes? They do have, I guess, theme Excel, if you want your plots to look like an Excel from 2003. You can do that. I don't recommend it, but you can. And like I say, in GG themes, there are a variety of themes. Pick a theme that you like, generally speaking, stick with it. I don't worry too much about this. I do keep theme minimal on most of my plots. Now, there's one thing that minimal, hard word to spell. All right, so this is the theme that I use, and again, I encourage you, try not to get too wrapped up in like developing your own theme. Find one that you like and stick with it, and I'll talk a little bit more about that in just a second. The one thing that I want to mention is in defining the overall theme, I have changed a lot of the elements that go into this. So what happens when I run a plot with theme minimal is it creates all of my plot, and then at this point says, great, let's wipe the slate clean in some sense of whatever theme elements have come before that, and create the plot according to the rules of this new theme. And that matters for the following reason. If I put theme legend position bottom first, and then I run theme minimal, the theme minimal is going to override anything that happened here, and it's not actually going to change. Right? So if I want to do both of these, let me get rid of this. If I want to do theme minimal and have the legend at the bottom, I have to update the overall theme and then tweak it a little bit to my own taste. And I can end up doing that, right? It's fine to be able to do that. Now, I did say, let me knit while I'm sort of shifting gears. All right, so this is themes. What I'm gonna talk about next is setting options. And what I mean by that, I'm gonna create a code chunk here, and I'm actually not gonna evaluate it now. But there are a variety of the choices that I have made that I like to just sort of apply to every plot that shows up in whatever document that I'm working on. And so I'm going to put some code here and talk through what it does. But generally speaking, this is code that I would copy and paste to the very beginning of an R Markdown document. And you'll start seeing this in whatever videos I work on from here on out. These are going to be options that I put sort of at the very beginning of a document. And so some of those options I'm going to start, just to sort of contextualize this, I would often start out with loading the tidyverse. And then I would do a couple of things that are plot related. I'm going to use theme set to determine whatever theme I want to exist everywhere inside of this document. And I'm going to use theme minimal overall, minimal. And I'm also going to add this theme. I'm just going to copy and paste from here. I'm going to add this theme legend position bottom. And what this is going to do is every plot, if I have this in my very first code chunk in an R Markdown document, this will load the tidyverse and then update the theme everywhere. Again, this is something that I will use moving forward, but I'm not going to run today because I want to continue to tweak some individual plots. All right, so that's one thing that I'm going to do is set the theme. I can also update some options, and I do this sort of a lot too. And these options are to override ggplot's default coloring. So here I'm going to say that ggplot to continuous color. I'm going to use the Viridis palette. And if I want ggplot2.discrete, or sorry, continuous fill, I'm going to use Viridis also. All right, so what this will take care of is both the color argument for a lot of plots and also fill for things like densities, or I think we saw on box plots or violin plots, you can fill the inside of those things. So I get both color and fill, should use the Viridis palette. And then the last thing that I'm going to sort of put in here is scale color discrete is equal to the scale color Viridis, and it's got these sort of superscripts here, sorry, suffixes here, D for discrete, and continuous, sorry, I've got, that's the wrong one. I need to do scale fill discrete. So this sort of works if I'm doing continuous things. Scale fill discrete, and let's do scale fill Viridis suffix D. And all of this stuff, I know it looks a little bit strange, and to some extent, don't worry about it. What all of these options are going to do is just make sure that every plot that I use has the Viridis color palette. These update the themes to be minimal everywhere and to put the legends on the bottom for every plot that I make. And then the last couple of things that I like to include that have to do with plots are a couple of knitter options that exist in the code chunk, and so I'm going to set a couple of these as well. And I'm talking about these now because they are related to knitter options that we discussed last time, and in particular, I usually have my figure width everywhere is fixed to be 6, and I do a figure, I could do height, I often do aspect ratio that says the height over the width, and I'll set this to 0.6, and then finally, I'm going to set output width, meaning that instead of having a figure that goes all the way from one side to the other, I kind of like my figure to be set in a little bit from the edges and with a little bit of visual separation. So I'm going to set this to 90%. My figure's, instead of being a full 100% wide, going to be shrunk down just a little bit. Again, right now, all of this code isn't going to do anything, but moving forward, I'm going to copy and paste this in the beginning of every single one of my R Markdown documents so that every time I create a plot in any document anywhere, it sort of has the visual appearance that works best for me as a person. So let me save this. I'm not going to re-knit because I haven't sort of changed anything. And this is code for setting options that I'll use later. Awesome. All right, so from here we're gonna take a look at a couple of things in ggplot that aren't exactly scales, and they aren't exactly themes, and they aren't exactly anything else. I'm gonna sort of make a couple of notes about things that you can do in ggplot that you might not have seen initially, and that sometimes can be a helpful thing to know. So in particular, what I'm going to do is look at data args in geom. All right, so what do I mean by this? I'm actually going to start with a really contrived example here, and maybe that's as far as we're going to get. So I'm going to get a Central Park data frame, and the way that I'm going to get this is taking my weather data frame and filtering so that the name is Central Park, New York, okay? And I'm going to do a similar thing to get a Waikiki data frame. I'm going to take weather and filter so that name is Waikiki, Hawaii. And let me make sure that both of these exist. All right, that works and that works. Okay, and now I'm going to start creating a ggplot object, and I'm going to do this saying, let's make ggplot, where I'm being very explicit here about what my data set is. Let's do this with Waikiki, and I'm going to define aesthetic mappings where x is date and y is the t max. Okay. And I'm also, I guess, here going to define color, although I've only got one data set in here. I'm going to define color equal to name, and then let's do geom point for this and take a look at what we have. So now I've got for Waikiki, I've got all of the individual data points that exist inside of my data set. All right, and I'm going to add a new geometry here, which is geom line. And what geom line does is sort of from left to right, it connects the dots, okay? All right, now what I'm going to point out, and again, this is a bit of a contrived example, but if I wanted one geometry to deal with one data set, it's going to assume this is the data set that I'm interested in, and it's going to pass that on to geom point and geom line. But if I wanted to use one whole data set in geom point and one whole different data set in geom line, you can actually update that data set here. So I'm going to change this to Central Park data, and now let me run this. Okay, I'm ending up now with a new plot. This new plot has one geometry defined using one data set and a different geometry defined using the other data set. And the way that I've gone about doing this is not trying to try to figure out how to make one geom apply to a subset of this data and a different geom apply to a subset of the different data. Like that would be a really difficult thing to do. What I've done here is instead created two different data sets and then use this data argument to determine which geometry applies to which data set is relevant for which geometry. Again, by default, just like geom line learns its aesthetics from the overall plot, and then so does geom point. By default, this one data argument is going to get passed on to every geometry, but you can do something different if you need to, right? And I think the way that I use this the most often is if I need or want to display a summary that I have computed from a data set that is somehow more complicated than the mean and the median, right? If I need to do stat summary, okay, that's maybe easy enough to do. But if I want to do some other thing, often I'll end up creating a second data set and including that in a data argument. Again, this is not the kind of thing that I expect you to use all the time or even particularly often, but it's helpful to know that it exists. And so that's sort of why I'm telling you now. So let me knit this. It's going to take a while to create all of these plots. And what have I done? What have I done? What I've done next is data args and geoms. Okay. So the data args and the geometries give you some way of getting like different behavior. I'm going to sort of turn my attention now to something like I'm going to turn my attention now to patchwork. And I'm going to start by saying, remember faceting. And what I mean by that is, suppose I wanted to take, let's keep with the weather data frame, and I wanted to do ggplot. What is something I might want to do? Let's do x is tmin, and color is name, and let's do geom density to get a density plot of the tmin temperature. Okay, I'm actually going to do fill by name. I think that looks a little bit better. And let's set alpha equal to 0.5. This all works well and good, but the reason I'm saying remember faceting is if this plot was much more complicated, then something that I might want to do is facet according to where there are no rows and I have columns that are according to name. and I end up with a 3-panel plot. Now, this 3-panel plot I can make using faceting. And the reason I can make this using faceting is that I'm creating the exact same plot, or using the same aesthetic mappings and geometries in this panel and in this panel. And in this panel, I'm just saying create that panel separately for this name, and this name, right? But it's sort of the same overall plot specification. If I wanted to say, put a density plot next to a scatter plot, that's not something that you can do using faceting. That is a different geometry. It's probably different aesthetic mappings. It's not going to be real easy to put plots of 2 different types side by side. So what we're going to talk about is what happens when you want multi-panel plots but can't facet. That's where patchwork comes in. And I prefer patchwork. There are a variety of other structures, other packages that let you do a similar thing. I think Grid Extra is another one. I kind of prefer patchwork myself. And I would encourage you to use patchwork instead of Grid Extra, but you can, I guess, use Grid Extra if you want to. All right, so let's sort of see what it is we're trying to do. So let me start out by making a few different plots. I'm going to say here, weather data frame. Let me pipe this into, I'm going to make a scatter plot first. And here I'm going to take the aesthetic mappings. I want same sort of thing. X is T-min, Y is T-max, and color is name. That wasn't close. Color is name. And here I said I want to do geom point. Let's do a similar kind of thing. Alpha equals 0.5. And I'm gonna update a theme for this just a little bit. I'm gonna do legend position is none, just sort of assuming that I don't really need it in this case. All right, so here's a first plot. Looks familiar. And one of the things that we've seen before is that you can save these plots for later, and so that's what I'm going to do now. I'm going to say Tmax, Tmin plot is that whole thing. Okay, so if I run this, it doesn't do anything. All I'm doing is saving this plot into a particular variable, and I'm going to start to do a similar kind of a thing. So suppose I wanted to get a precipitation density plot. I'm going to take my weather data frame. I'm going to put that into ggplot and define the aesthetic mappings, where x is the precipitation variable, and I'm going to fill this density plot according to name, and I'm going to add geom density, and let's also sort of set alpha equal 0.5 here. Let me sort of take a look at what this looks like. Okay. There's sort of a lot going on here, but I think this is mostly going to work for me. Maybe, do I like this? Yeah, it's getting me. I mean, like, part of the reason that I'm not a huge fan of this plot is that there's probably some things going on in the tail over here and even here that I'm not really seeing. And part of the reason that that's happening is that almost, or a very big proportion of the days, there's just no precipitation to speak of. And because I've got almost no precipitation to speak of, you get this really big spike here at the beginning. So I'm going to update this using a little bit of filtering. I'm going to filter so that the precipitation is greater than 0, right? So first, if I just take my weather data frame, I've got all these days where precipitation is equal to 0. I'm going to take those out and just keep ones where it's larger than 0. And now let me sort of put this in. All right, that looks a little bit better. Again, I sort of have to know, or would need to communicate somehow, that this precipitation is only for days where there is more than no precipitation, but it gives you some idea that, you know, it sprinkles a lot in Waikiki and then pours occasionally. But if it's going to rain in Waterhole, you sort of get a little bit more rain than you would get in Waikiki. That's sort of what we're learning from this plot. All right, so I'm going to save all of this into a precipitation density plot. And then the last one that I'm going to make is sort of a seasonality thing. Let's look at Tmax against date plot. I'm going to start with weather data frame, And this is going to be sort of broadly similar to a plot that we had seen before. I'm going to say X is date and Y is tmax and color is name. And let me add in a point geometry to get a scatter plot. And let me do a geom smooth as well. I'm going to say that standard error is false. And I'm actually going to copy this theme legend position is none to each of these plots. Right? So let me first run all of them and make sure they're all updated. And let me double check this. All right, so the individual plots here matter less than the idea that potentially what I would want to be able to do is organize all of these things into a single figure. And that's where patchwork comes in, is if, for example, I wanted to put this plot, a scatter plot, next to a density plot, or have that be organized around another plot, another scatter plot that has sort of fundamentally different arguments and geometries and mappings, well, that's a difficult thing to be able to do no matter how you've organized your data set. So creating individual panels, right, you're not going to be able to facet to create these, but if you create a few individual panels, you can use patchwork to organize these things. And the way patchwork works, it takes a little bit of time to get used to the interface, and I encourage you to sort of go to the patchwork web page and see a little bit more. But the idea is that you could do something like my tmax tmin plot and a panel for the precipitation density, and you get sort of two side-by-side panels. I could do precipitation, I could add to this the tmax date plot, and it would give me 3 panels side by side. I can do a couple of different things. I could sort of put these two together. Let me sort of see. That's about the same, but by putting these two together, I've said give it about as much space as this one and sort of have scrunched it up a little bit. I can use division to say put this here and the other 2 panels below. You get some options. And again, a lot of these are features that you can tweak. You can make the rows larger, smaller, narrower, whatever. You get some control here. But this, broadly speaking, is how I would combine multiple panels. So let's do plus, get rid of this one, get rid of this one. I'm going to put these 2 together and put the seasonality plot below. Neat. Awesome. Love it. Okay. Let me knit. Takes a minute now because I'm making an awful lot of plots. Okay. And what did I add here? Patchwork. All right. So in this last little bit, we're going to start taking a look at some of the things that can happen when you're trying to make a plot to get an idea of how data manipulation plays into that plot. And this, I guess like I'm hesitating a little bit here because I want to be clear that this is not easy, and it's not easy because a lot of it has to do with developing a real firm understanding of data manipulation and a real firm understanding of how ggplot works and how those 2 things sort of interact with each other. A lot of the things that we've seen up to this aren't easy either. It sort of takes some time to figure out like, oh, what do scales mean and how might I use patchwork to organize multiple panels. But I think it's a little bit different in the sense that those are specific tools that you might use to update or modify a plot to make it more visually appealing. What I'm going to talk about now is sort of the interplay between data manipulation and a plot object. And so if this part is hard, I guess sort of what I'm saying, if this, boy, seems like an awful lot, if this is challenging or difficult, like there's a good reason that is. It's that you are learning an awful lot of stuff in a very compressed time period. We are thinking of these videos as ones that follow immediately after introducing import data manipulation and tidiness, and now we're sort of throwing all of that together. It's a lot to be thinking about all at once. So if this part is a little bit confusing, take your time, think it through, review some of the code, think about it a little bit more, but don't get discouraged that this is not easy. All right, so let me sort of get started on this. So let me sort of go into data manipulation. the first thing that I'm going to do in terms of data manipulation, I'm going to start with a plot here. Let's take my weather data frame and pipe this into ggplot. And I'm going to say here, I'm going to make a violin plot because, gosh, I like violin plots mostly. And so what I'm going to have here, I'm going to say that x is tmax, and that wasn't right. Y is tmax, and x is the name variable. And then I'm going to create a geom violin. Let me sort of put color in here also, just because I can. This is an instance, I guess I want to be clear. I'm putting color into this plot, even though it is not strictly necessary, right? I guess fill is the appropriate thing here. It's not strictly necessary to have color in this plot because color is redundant for whatever is on the x-axis here. You don't need color to distinguish these groups. I'm putting it in here because you know, it's a little bit superfluous, but sometimes it's nice to do this visual distinguishing. It's also helpful if you're going to be making multiple plots to keep that coloring consistent across multiple plots, so that it sort of, if it exists in one, it exists in the others, right? Like that's, I don't know, maybe a stretch for why I need it, but whatever. All right, I put in color, but that's not really the issue that I have with this plot. The issue that I have with this plot right now is that the name argument might not make perfect sense, right? So what's happening is not that it's going from highest to lowest or lowest to highest. It's going in alphabetical order according to this name. Now, that is a choice that ggplot makes, and it makes that choice for a kind of convoluted reason. In the data set that I have, the name variable is a character. When it comes time to making plots, all of those character variables that are included in an aesthetic, whatever that character variable gets converted to a factor. And factors in R are represented by numbers with these sort of text labels. So what's really sort of happening behind the scenes is ggplot is saying, let me take this character and I'm going to call this 1 with a Central Park label. So here's 1 labeled Central Park, and here's 2 labeled Waikiki, and here's 3 labeled Waterhole. And if I wanted to put these in a different order, I both sort of have to know what ggplot is doing with factors. It's putting, by default, a character variable, converting it to a factor, and putting it in alphabetical order. That's sort of one piece of things. And then I have to ask, is there some way that I can override that? And we haven't really dug into how to work with factors yet. We will in a second collection of data wrangling videos. The point that I want to make here is that to put these in a different order, instead of going into ggplot and trying to figure out, gosh, how am I going to move this over to here as a ggplot issue, that's not really my issue. The issue that I have is that I want these to be factors, and I want them to be in a particular order that I specify. And so that's sort of what I'm going to do, is manipulate my data differently using some factor stuff that we haven't really gotten into yet, but it's a data manipulation problem, not a ggplot problem, right? So how might I go about fixing this? Again, I'm going to do this, not anything in ggplot. I'm going to change the data set first. So here I'm going to mutate. I want to change that name variable, and I'm going to be first pretty specific that I want name to be a factor version of name. Okay, so let me first just run this little bit of code, and it doesn't look like anything has happened here, but it has in fact changed name from character to factor, and that updating has assumed that everything is in sort of alphabetical order, that Central Park is 1, that Waikiki 2, and Waterhole is 3. That is the number that is behind whatever character label we're looking at. And we'll worry a little bit more about this later on. And if I just take this, to be clear, and pipe it directly into ggplot, I'm going to get the same plot, because that coercion from character to factor is sort of the same whether or not it's something you do by hand or something that ggplot does. Now, again, this is maybe not something this is absolutely not something that we've spent time thinking about up to this point, but I am going to sort of be clear here that if I wanted to change the order of these things, I would do that in updating the factor variable rather than in trying to do something in ggplot. And so here, just as sort of a preview of things to come, I'm going to use the forcats package and the factor relevel function. And I'm going to relevel the name variable, and I'm just going to tell it which one I want to go first in this case. So I'm going to say relevel this so that Waikiki, Hawaii is my first factor, and then it's going to assume that everything else is in sort of the correct order. I could say I want this to be Waikiki and then Central Park and Waterhole or something else, but I'm just going to sort of put this in this particular order. And so what that's done, again, sort of behind the scenes, when I look at this data set, you almost can't tell that anything has happened, not without really looking at what's going on in factors. But this now has weather data frame, name is a variable, and behind the scenes, Central Park, the label has stayed the same, but the number behind this is now 2. Waikiki would be 1 and Waterhole would be 3. Right? So I've done some data manipulation, and that data manipulation is the thing that's affecting my plot. Okay, and there are some other ways that we might try to organize these things. Here I have done this releveling by hand. You can, especially in the case when you have more factors that you're interested in, you can do that releveling according to like the mean or the median within any particular group. You can relevel according to a variety of other things. Like there are ways that you can manipulate these factors. That's not the main point that I'm making right now. The point that I'm making now is, rather than, in this case, rather than try to reorder some categorical predictor on my x-axis, that's not business that I want to do inside a ggplot. That's something that I want to do using data manipulation first. Okay. What I'm going to sort of do next is start by saying, all right, so control your factors is an important message here. So then another thing that I'm going to sort of take a look at is what if I wanted densities for Tmin and Tmax simultaneously. So here, sort of what I'm saying is, could I get on a single panel, could I take one panel and have the Tmin and then have the Tmax? Okay, and let's just say for now I only want that for Central Park. I want to know, like, for example, is the Tmax distribution just the Tmin distribution plus 3, or does it look a little bit different, right? So I want to have Tmin and Tmax overlaid on top of each other. And again, for now, let's sort of say I'm curious mostly about Central Park, okay? And so I'm going to start out, and I'm going to think about this first from a data perspective, and then think about how that maps onto a figure that I want to make. So I'm going to take my weather data frame, and first I'm going to look at it, right? I guess I've been looking at this a few times. I've got name, I've got ID, I've got data, I've got precipitation, Tmax, and Tmin, okay? And like I said, for now, I'm just going to worry about Central Park. Okay. Now, if I wanted to make a figure that showed Tmax and Tmin, gosh, that would be a hard thing to do, right? So one option, I guess, in ggplot would be to take my data and define one set of aesthetic mappings and then change the aesthetic mappings in a second geometry and sort of cross my fingers and hope that that works, right? But that's not really going to solve my problem, I don't think, and it's a little bit convoluted. And part of the reason that this is convoluted is that in this data set, if I wanted to show both Tmax and Tmin, my issue is really one of data tidiness. That what I actually have here is temperature. All of these are degrees Celsius. This is a temperature and this is a temperature. And this is sort of the Tmax temperature and the Tmin temperature. But so I guess like what I'm saying here is, for the plot that I want to make right now, it's not so much an issue of ggplot. It's recognizing that I want to make both of these things, I've got a variable in the column names. I've got a Tmax here and a Tmin here, and that's sort of what my problem is. And so what I'm going to do, and if that doesn't make sense, once we start seeing some of the plots, maybe it will. What I'm going to do is try to tidy up this data set by pivoting to a longer format. So again, I've got Tmax and Tmin, and those are both temperatures. So I'm going to say, let's look at let's pivot the columns Tmax to Tmin, and the names are going to be, let's call this observation. And observation, I mean either minimum or maximum, and the values are going to be temperatures. Okay. So now, if I take a look at the data set that I have, hopefully it's starting to be a little bit easier to see maybe where I'm going. So eventually, what I want to create is a density plot that shows temperatures as the variable on the x-axis, and I want to separate somehow the minimum and the maximum. I want one density for one collection of temperatures and another density for a different collection of temperatures. But the biggest issue in coming up with this was not figuring out how to make ggplot do what I wanted it to. It was figuring out how I was going to organize my data so that ggplot sort of did the right thing at the outset. So let me take this and actually make the plot. So I'm going to define my aesthetics. On the x-axis, I want temperatures. On my y-axis, actually, I don't think I need anything. And I'm going to define fill according to observation. And now let me add in the density plot and take a look. Let me change. Alpha is 0.5. Okay. So now, again, what I've got is a temperature distribution for Tmax and a temperature distribution for Tmin. And this is helpful in the sense that it's sort of indicating that it's not just the case that Tmax is Tmin shifted to the left. There's maybe a little bit of different feature here. You get maybe a higher spike here for Tmin than you would do in the corresponding Tmax, right? It's hopefully, I don't know if this is super informative, but it is the sort of question that you can go about asking. And I'm just going to sort of play around with this a little bit more. I'm going to get rid of this filtering business, and let me do facet grid here. Since I've gotten rid of the filtering for Central Park, I can facet now according to name and make a plot that shows me sort of what the sort of horizontal separation between minimum and maximum temperatures is. Waikiki, it sort of looks very much like whatever your cold temperature, you shift it and you get the warm temperature. Waterhole seems like it's got like a little bit more of like a high temperature bump off to the side, and Central Park, you get sort of like you get slightly different shapes. Okay. How interesting this plot is might depend on how much you care about temperatures in these three locations and the difference between min and max. But again, the point here is that if you needed to make a plot like this, doing it just using ggplot is going to be hard, but recognizing this as a data tidiness issue is going to make your life a little bit easier. I am going to do one more quick example, and when I say quick example, well, we'll see a little bit how quick the example turns out to be. So let me actually, I'm gonna, before doing that example, I'm going to go ahead and knit this. Takes it a sec. Lots of plots. Lots of plots. All right. So this is, what did we do? Data manipulation as part of plotting. Okay. So let's sort of here at the end revisit the pups. So we've seen a data set a couple of times, and I guess, all right, so part of the reason that I want to revisit this example is to drive home the idea that the data manipulation and the data importing and the data visualization, a lot of this is all sort of interconnected. And so there's some amount of what we're going to do now that is just quickly reiterating some of the data import and manipulation things that we have done previously. But then we're going to see what happens if you want to start doing a plot based on these things. So the first thing that I need to do, this is data from the fetal alcohol syndrome study. If you recall, at the beginning of the first lecture in this collection of 3, I pointed out that in my repository and folder, I've actually copied in all of these data sets. That was one of the things that I did here at the outset. So if you're following along yourself, make sure that you have these data sets available to you. What I'm going to do is revisit some of that data import and cleaning stuff. So real quickly, my pups data set, what did I need to do? I read CSV from the data directory and the FAS pups, and I think that's going to be enough. I'm going to do janitor clean names, and here one of the things that we did also was updated the sex variable, because this always bothers me. I recoded this from 1 to male and 2 to female, and let me just double check that this works. Yep, that looks right. So all right, so I've got my pups data set. Next thing I'm gonna do is get my litters data set using a similar process, read CSV from the data subdirectory, FAS litters CSV. I'm gonna use janitor to clean the names. What else do I need to do? All right, so I sort of, a couple of things are going on here. I've got this group, I've got con 7 and con 8, and one of the things that we talked about previously is that really this is probably a dose variable and a day of treatment variable, and so that's sort of what I want to take a look at next. So I'm gonna separate this. I'm gonna separate group into dose, really hard to type, and day of treatment. And again, we sort of said in separate, there are a variety of ways that you can specify where to do that separation. So I'm just going to designate separate after 1, 2, 3 characters, and that's going to give me this data set. Okay. Con 7, day of treatment, litter number, and so on. We probably previously did a little bit of like relocating litter number to be at the very beginning. We may have done some other things as well. I'm not going to worry too much about that for right now. What I am going to do is create a fetal alcohol syndrome data set that is left joining into the pups data set. Again, pups has information on individual pups, and I'll talk a little bit more about this in a moment, but it's got individual pups in each of these litters, and so I want to merge data on those litters from the litter data set according to that litter number variable. So I'm going to left join into pups the litters data, and I want to do this by litter number. Not found. Pup data. Better. Litters data not found. Got everything. Okay, so let me take a look at what I have here. I'm actually going to say FAS data. Let me view what's going on here. I've got litter number, I've got sex, and I've got a variety of outcomes here. The outcomes I'll touch on in just a second. I've got dose, I've got day of treatment, and I've got some other information about the litter and about the mother, right? But what I want to focus on mostly are these sorts of things. All right, so I've got dose and I've got day of treatment. I've got a control group, I've got a low dose, and I've got a moderate dose, and then I've got days of treatment 7 and 8. Now I also have for each pup a variety of outcomes, right? So what these are, the prefix here stands for postnatal day, on which essentially the ears started working, and the postnatal day on which the eyes started working, and the postnatal day on which the pups were able to pivot, and the postnatal day on which the pups were able to walk, right? So each of these is a particular outcome, and what I might be interested in, for example, is understanding what the distribution of postnatal days on which the ears unfolded looks like, comparing control to low to moderate. And I might also want to know what that looks like if I'm looking at day 7 or day 8. So let me start with something that looks like that. So if I wanted to say, take my fetal alcohol syndrome data, and here I want to put this directly into ggplot, and I'm going to say that my aesthetic mappings let's say on the x-axis I have that dose variable, and on the y-axis I have PD ears. Let's do geom violin. If we're making violin plots, we might as well make violin plots. Let me take a look at what this says. All right, so I've got a couple of things going on here. I guess first I've got dose sometimes is missing, but I've got the control and the low and the moderate doses for PD ears. Okay, so this is fine. I could do a couple of other things. Let me say, what if I did facet grid according to day of treatment, and I get sort of another plot here. Again, there's sort of, it looks like missing data in dose and in day of treatment. I'll probably get rid of that in just a second, but this gives me some idea. All right, can I compare control here on day 8 to control on day 7? Can I see whether or not there's a difference between day 7 and day 8 for the low dose or the moderate dose? Can I compare the day on which the ears started working from control to a low dose to a moderate dose, right? Those are the sorts of comparisons that I might want to make. Now, I could create an awful lot of these if I wanted to do PD ears and PD pivot and the day on which the pup is able to walk and the day on which the eyes are able to open. But if I wanted to create a figure that shows all of those, what I'm going to sort of argue is that that's, again, not a ggplot issue. That's really a data processing issue. That's a data manipulation issue. And what I mean by that is I've got outcomes that I care about. I've got an ears outcome and an eyes outcome and a pivot outcome and a walk outcome. And all of those outcomes are measured on postnatal days. So really, in these 4 columns, I have postnatal day and outcome that I care about. I have postnatal day on which the ears started working, on which the eyes started working, on which the pup was able to pivot, and on which the pup was able to walk. So to make a figure that shows, for example, ears, eyes, pivot, and walking, different dosages, and also day 7 versus day 8 of treatment, that's an issue of data manipulation, an issue of data processing, right? Rather than something that goes into the ggplot thing itself, right? Instead of manipulating some argument, I really just need to clean my data a little bit more, or organize it a little bit better. So I'm going to focus in on a couple of things here. First, I'm going to get rid of some variables that I don't need. So I don't really need litter number. I need each of these outcomes, and I need dose and day of treatment. And just for the sake of keeping things simple for organizing this plot, that's all I'm going to keep. So let me do dose, day of treatment, and everything that starts with PD underscore. That looks right. And I'm also, just because I can, I'm going to drop NA values here. Drop NA. Actually, I'm gonna hold off on that. If I drop NA now, I will get rid of this entire row, and I'm gonna wait so that I can sort of keep this data at least instead of getting rid of everything in this row. So I'll hold off on drop NA, but I do need to do my wide format to long format. So let me do pivot longer. And the columns that I need to pivot are PD ears up through PD walk. I'm going to do names to outcome and values to postnatal day. Okay, hopefully this is going to give me a tidier data set. Little bit tidier. Yeah, so I've got dose, I've got ears, eyes, pivot, walk, and so on. So I'm gonna try now to make a plot, and here instead of, I think want dose on the x-axis, and instead of just looking at y is postnatal day ears, I'm gonna do a couple of things at once. I want y to be the outcome that I'm interested in, and if I just run this, I'm gonna get a plot that doesn't make a lot of sense if it even works. This, gosh, it's sort of showing a lot of stuff. I've got eyes, day 7, day 8, there's a lot. I've also got missing values that I sort of need to get rid of. So let me do a couple of things here. I'm gonna drop missing values. And the first thing that I'm gonna do here is make sure that in my plot, I wanna do, say 7 and 8, day of treatment against dose. Or sorry, I want to do that almost had it right. I want to do day of treatment against the outcome that I'm interested in. So there's a couple of things that I did wrong in this. I guess instead of outcome, this is sort of plotting PD, walk, eyes, pivot, things like this. Really what I want is that postnatal day. So let me run all of those. And now it's getting real confused. That's probably not my issue. Sorry, I dropped NAs and then didn't put in my pipe. It's a complicated plot, I hope you see. So let me try this again. Okay, so I'm getting a little bit better in the sense that I have postnatal day distributions, 7 and 8 according to dose. What I haven't done successfully yet is separated out the outcomes. So if I wanted one plot that has to do with ears and then another with eyes and another with nose and another ears, eyes, pivot, and walk, sorry, what I need to do is separate out each of those into separate columns. So I'm going to do day of treatment against outcome. And this, I think, is actually starting to be a little bit informative in the sense that now I can say for the ears outcome, how do things look for control low and moderate on day 7? How do they look for control low and moderate on day 8? And then what about the other outcomes that I have? Eyes, pivot, walk, and so on. There's a little bit of additional data manipulation that I could do here. In particular, I could try to order these according to which one came first. So here it's sort of going from ears, which happens really early postnatal day. The ears start working. But then what happens next sort of chronologically is that the pup is able to pivot and then walk and then really the eyes open. So let me just sort of say this is another thing that we might do. And again, to do that reordering, that's not a ggplot issue, that is a data manipulation issue. So here I'm gonna skip a step, and this is a piece that until we really get into factors might not make total sense. But I'm gonna organize using forcats. I want to factor reorder the postnatal day. I want to reorder outcome according to whatever. I'm getting confused here. I'm instead of trying to use factor reorder for now, I'm just gonna put these in order. PD ears, PD pivot, PD walk, and PD eyes. And let me pipe this whole thing in. Oh, that's not working at all. Factor relevel outcome. That's better. So again, this last step involves factor manipulation, which is a thing we will worry about in a later video. And the goal for this is not so much to worry about factors, and it's not so much to worry about maybe what specific things go on in one of these steps. It's really to emphasize that if you are going to make an informative plot, very often you're going to have to spend some time thinking about the data manipulation that you need to do to get to that point. This plot is the sort of thing that is potentially very informative for you and for somebody else, but it's not always real easy to get there. And so thinking through, again, that the sort of two processes that are happening at the same time, the one of them that has to do with making the plot and one of them that has to do with the data manipulation, that's what I want you to spend at least a little bit of time thinking through what it took to make this plot. Now, again, I want to emphasize that you're covering a lot of ground really fast. We've gone pretty quickly through data import and manipulation and tidiness, basics of ggplot, and now some sort of advanced features of things that go on in ggplot. That's an awful lot to digest. So I'm happy with the progress that you're making. I understand if you're a little bit knocked back, but you're gonna be okay. You're doing great. You're gonna get this. It's all gonna be awesome. So I'm gonna go ahead and stop there. And thanks very much for following along.